Ladies and gentlemen, please welcome Moira Gunn and Steve Wozniak.
Hi, everybody. Hi, Steve. Great. Welcome, welcome, and it's good to see you, Steve.
Oh, it's great to be. I'm glad you're doing this again.
Thank you, thank you. You know, one of the things that I thought was really important when I was reading your book was, for me, it's the engineering, not the glory. And so here we are at the Intel Developers Forum. We got lots of engineers. What's the essence of engineering? What does it mean to be an engineer?
I don't know. It means a lot of math abilities, calculating, being able to think logically and put this to this will cause that to happen, and this won't be an escape path for the electrons. It's a real intense mental effort and a lot of diligence and care. You have to make sure every single thing will work. You start out and you think, oh, wow, you whap this chip together and that chip together and just where you kind of hack it together. You finally learn, no, every little thing has to be thought out and check the voltages and compare things. So it's a long jobs with a lot of diligence.
You say, I spent a lot of time trying to explain my designs and inventions to people who didn't know what I was talking about.
I'm not sure what that's referring to, but very often I had very different approaches to things. I was very much self-taught, so I would usually show my circuits and my code to people, and it was a little different at first. And once they got it, it's so compacted that it was easy to understand. And then they appreciated it. And it was my style.
All of us are working on so many specialty areas. When somebody asks us and they really want to know, it's like then they say, well, I'm really kind of sorry I asked.
But you got it right. I'd rather be known as a good engineer than whatever happened in computers and all.
Exactly. I guess the reason I asked you that is back when you were first dreaming, designing on paper, building, prototyping, if you will, portions of a personal computer, did people know what you were talking about?
Oh, a number of us. I was in a tech group, so we have our own little outside group. We can't talk to normal humans, but and we were all. But we had these dreams that the computers would affect all of society and improve education, improve people's communication, and let us achieve a lot of tasks short of what we can do today. We couldn't quite envision that far ahead. The internet and broadband everywhere, but. A lot of us in our group understood it. But we had a technical group that was only thousands of people throughout the United States, mostly engineers that were interested in a hobby.
I think the reason I say that is that if you're really breaking frontiers, if you're really out there at the edge and you got some new stuff happening and you're trying to revolutionize, a lot of people can't conceive of what it is you're trying to do.
It's very strange because a lot of products, you know exactly where they fit into today's markets and today's other existing consumer electronic products and the like. What we were doing was a little bit rare and outstanding. It was not how to build a computer, how to get a computer that can go in a home. Price, looks, features, all that stuff. And that was really a tough challenge. And it was just like, we were put down. A lot of people were saying what we were doing wouldn't go. So that inspired us. It gave us more passion. We used the word revolution all over the place. This is going to be a revolution. It's going to be a computer in every home. And looking back, it was kind of extremely outrageous to say that, but it sort of happened.
Oh yeah, that's the kind of Julia and my potatoes. Well, it's not a home computer. So we have to solve a lot of problems to figure out where it really fits in our lives. I have to say, we are going to be talking about today, but not today in the sense, people always say to me, what's the latest, greatest, what's the technology happening? What we're talking about, I think, is where we are today as engineers and innovators. And sometimes you may not even be an engineer, but you're conceiving of the innovation. You're leading a team. You're trying to take a new paradigm to the public. We're looking at changes. We're looking at all those things that make a total product out there. And so I think it's important kind of to go back and sort of see how you got where you got for a number of reasons. Because what you ended up doing didn't even exist in the minds of many people when you first started out. And I'm talking about when you were a real little guy, when your father was explaining electrons to you and telling you how components work, like diodes and things like that.
Well, it was, just total accidents. Fell in love with a certain thing in life. I want to understand how circuits work and where the electrons flow and what causes what to happen. And you just fall in love with it.
And how old were you?
I had siblings. They didn't become engineers. I was doing really advanced computer projects, actually, by the time I was 10. Building things like tic-tac-toe computers with hundreds and hundreds of transistors. Every transistor would make one decision.
And as a parent, you'd say, oh, employable skills. This is good.
No. Even when I got out of high school, I figured my love in life is computers and designing computers. I just started designing them on paper for my own self. And I never thought I'd have a job doing it. I didn't think they had jobs. Computers were kind of rare. They were in some big military outpost called research or something. I had no idea how you get to computers. I thought engineers build televisions and radios and all that stuff, and that's what I'm going to be.
Now, you were ahead of the game, obviously, at 10 years old, and then you got to high school. And here you are in electronics class, which is really where they usually put the low achievers. We're going to send you over to the bench.
No. Sometimes it's vocational, but you always have a few of the top math science students like myself take electronics as well. And when you combine math ability with electronics circuitry, that's sort of the essence of engineering.
And you don't exactly know where you're going at this point still.
Oh, yeah, I knew I was going to be an engineer.
No, but you didn't know about the personal computer.
Oh, no. I just loved computers and what they were and ones and zeros and how they added and how logic worked.
And it was somewhere in there that you found the Small Computer Handbook.
I found what?
The Small Computer Handbook.
Oh, yes, I accidentally discovered the Small Computer Handbook that described the architecture of one mini computer of the late 60s, a PDP-8. Big PDP-8 with the switches and lights, zeros and ones, and push a button and you can get some zeros and ones into memory. And wow, now that I had a description of a computer, that's when I started designing them. I sat down and pulled out chip manuals, and my dad was close to the chip industry, which was starting up. You could get, one NAND gate on a chip, and then all of a sudden you could get 2 the next year. And you could get 4, and you could get an adder on a chip. So I started designing how these chips would make a computer and figured it out all by myself. No books, no nothing. So it's a very good form of learning.
And how old were you at that point?
I was, like 16.
Like 16. Got a whole life ahead of you. So this is...
Yeah, like junior in high school by then.
Junior in high school. I love it. Okay, so then that was your first computer manual for a mini computer. Mini computers were the smallest we had. We thought those were really hot at the time. But then you started collecting manuals.
I started getting manuals. I got them at Stanford Linear Accelerator Center. I would drive over. I figured they were the only place that had a top research library, and they have very smart people that work there, and wherever smart people work, they leave doors open. And so my friends and I would drive in on a Sunday, and we'd always find at least one door open to the building that had the library, and I could read computer magazines, and I could order manuals. So I just started designing every computer I could get a manual for, just for fun. I didn't even tell my parents. I'd shut the door, didn't tell any friends or teachers. You just want to do some things. Your rewards are just in your head. You're doing what pleasures you, and you're not getting a salary, a title, a grade in school. You're not getting any of these visible awards. Just your reward is, invisible. It's what you like to do.
You said you were so shy you couldn't imagine asking the librarian for a book on computers. There couldn't have been a lot of...
Yeah, I was that shy. Even designing the Apple computers, I attended the most important meetings of my life, a homebrew computer club. Group of people, a little smaller than this, and it was the most important day of my life, and I only listened. Never once raised my hand, never once spoke.
And here you were designing all this stuff.
But that shyness helps you not have to go along with the way other people do things, too.
Well, I guess you don't get into...
It helps with a streak of independence. And
that's what you need for revolutionary.
Yeah. And the important thing is know your goal. I know what I want to build. A computer that can solve, do my logic simulations at work and can play games. I can build these pieces together and it will do that much. I don't know if it's a computer by other people's definition, but here's the cheapest way, the only way I can afford to do it. Lack of money is the big help. Sometimes when you're short of resources, not zero, but very short of resources, it forces you to do better work, better thinking, think a little harder, and come up with better solutions. Like all the code I did for the Apple II, it's like 2 pages thick, 200 pages thick in a manual, wrote it by hand, and I couldn't afford an assembler, an online timeshare computer system to type my program into, so I had to write down the ones and zeros the program equated to, and then enter those ones and zeros into my own machine, all done by hand, never once on a computer.
I think part of the thing that people don't understand is like, oh, so you read all these manuals and you learned how computers worked. And the truth is that you'd read the manual and then you'd start going back to the logic design to see how could I build it, better and faster, even though these are major manufacturers.
Yeah, and I did not look at other people's designs. I saw the architecture, but not a design. I had to come up with my own designs. And, I don't know, it was very good. It's a good way to learn. When you do something yourself and you have to think it out and figure it out and solve it, you remember that forever. And your brain now has a new trick to apply to other designs or other programs forever.
And those new tricks, are they sort of new things that you end up incorporating then in new designs?
Absolutely. And those tricks were in my head, and I knew that some of the tricks were so weird, you'd never find them in a book. Ooh, I need a spare inverter, And timing doesn't matter. I could use this extra unused pin on a register chip, and it will do the inversion. I mean, I do any trick I could think of not to waste a thing, trying to save money. But when you have no money, it really helps.
And that takes you up through your early 20s? This is where when you're doing this? So at this point, you've become an engineer, graduated from Berkeley.
No, I was attending college. I had not graduated. And I got a job at Hewlett-Packard designing scientific calculators, the handheld calculators. Everyone passed the HP 35, and I was very lucky. Because I could design, they interviewed me and hired me because I was good at doing the engineering, but I didn't have a degree.
Now let me ask you this. A good portion of this is the fact that you sat down, and I don't want to use the word self-taught, because we have that sense that you read a lot of books and sort of got trained, or something was put into you facts. What you did is you self-skilled. You created skills for yourself.
Well, sometimes if you sit down and you haven't done this exact thing before, I'm going to look at the components that are available, the chips or whatever, and how can I make them do the job that needs to be done? And it's like you're writing the book of how to do it rather than having read it or taken a course on it. I mean, the longest one I did of that sort was I had to have a computer that was worthwhile, I had to have a programming language. And I looked around and sniffed the air, and BASIC was the right language. I'd never programmed it in BASIC in my life, but Bill Gates had written a BASIC. So I sat down there and said, I've got to write a BASIC. And I pulled out some manuals of BASIC at work and started writing down the syntax diagrams. I had never taken a course or read a book on how to do it, but I learned how to write a structured technique to write a computer language. I don't know where it came from, but if you're smart, you can figure out a way to do it. And if you use the current components that are available, like the current chips, you're going to do it better than somebody who came up with the techniques for 5 years ago chips and knows how to do it all the time. You're looking at it fresh. How can I use the absolute best combination of today's parts?
Having engineered things by committee to some unfortunate results, you say engineers work best alone.
Well, I was lucky. When you have a committee, I mean, basically any big inventions and the big things that really change our lives a lot, whether they come out of Intel or they come out of something like Google, they generally come from small groups. And you have groups within a company. And within a company, even other huge conglomerates aren't really necessarily better than you. You're a small group of people, they have a small group of people. You can be on your own. Maybe it's Google, maybe it's Apple, and if you do good work. Now, in my case, I was very lucky. I did all of the engineering, the hardware, the software, the technician, the testing, and all that. So I didn't have a whole bunch of inputs that had to vie, and everybody wants their piece into the final product. You want one head to have good control over any product, to keep the consistency, to keep it feeling like this is one understandable thing, and it's not just does a whole bunch of things that somehow they don't fit together well.
Now, if we roll to get back to today, I mean, we've got chips coming out all the time. We've got software that we can interface with. We've got platforms. We've got all kinds of options to put things together. How does the innovative process that you were using, if you will, compare to today?
Well, today's a different world. You're describing a world that's very huge, the world of computers, of personal computers, of everything they do, of microprocessor chips and everything they're used for. And it's a huge much huger market today than it ever was then, so it's more understood, and there's a lot of people there. People like myself, I'm more independent, kind of the inventor spirit. You want to work on things other people aren't. You just want to be doing your own thing that's somehow different than something else, somehow unique. So I probably wouldn't be in the same space today.
But if you were in that same space today, it seems to me...
If I were in the same space, I'd look for some way to do it differently, I mean, even Intel has talked about, like, using photonics instead of electrons to do logic. Imagine, a chip where you have one fiber optic cable coming in, one coming out, and there's no battery, almost. I mean, something that's so new and rare that didn't exist before, and hopefully it has a benefit. Hopefully it's better for cheaper.
I have to say that some of the things that you've been talking about as we go along, and I want to know everybody out there that we do have questions that you can give us over the web, both here and people who are seeing us live. So don't hesitate to put those up. I do want to ask you about a whole other start of your life, and we talked a little about you being shy, and that's been throughout your life. But also, you were a big prankster.
I was a big prankster, and all through high school, thank God, I was so shy that I had learned, don't ever tell anybody what you do. So only you can get the benefit of seeing your prank work, but you don't get caught. If one person knows, they tell somebody, guess what so-and-so did, and the word spreads like wildfire, and the teachers know it. So,
Well, you did spend that night in juvie.
yeah, I did. I only got caught for one thing in high school.
And then
The cops lied.
And then you taught your colleagues your esteemed colleagues in juvie a trick.
Oh, I taught, yeah, that's right. In juvie, I thought, oh my gosh, you always hear these stories about, criminals teach other criminals how to do crimes in prison. So I looked around and I said, what can I teach? I only know electronics. I said, well, there's wires up there on that fan. If you touch them to the jail cell, then when the guard comes, he'll get shocked. I just felt it was like what you're supposed to do.
Yeah, this is really great. I wonder how much longer they spent in juvie.
But, and the laughter's worth it.
And then there was that other prank you played in college about what was it, the TV interference thing.
That was fun. In college, I went down to the Radio Shack my first year of college and found the highest speed transistor they sold. And then I wired around a little coil and put a couple capacitors on, made a little oscillator that I could tune, and it would hit TV channels. And it would fuzz up the TV picture. And then I would get people to go up to the TV and whack it, and it would go good. Or I'd get them to twist the knobs and go good, and they pull their body back and it goes bad. And they started saying, where your body is matters. So I would get them I got one guy to hold his hand on the middle of the TV for half an hour of Mission Impossible to get it to work, and his foot was in the air on a chair as he stood up just to make the TV work. Or they'd climb up on chairs and hold the antenna in the air because it made the TV work. And I had a lot of fun. It could have been a great psychology experiment.
Now, given all those things, you obviously kept inventing and inventing and inventing. Do you still invent today?
No, not the same way. When I did that, I had an awful lot of time and nothing else to do in life. I had no hope probably of ever having a girlfriend or a family to worry about, so even when I came home from an engineering job, I still wanted to do electronics, fun projects on the side. And it was so intense that I knew that the sort of thinking to solve, especially you get down to like 4-bit microprocessors, if any of you guys remember that, and you're trying to make the code work out. It's so difficult and hard. Unless you want to be sloppy. But if you want to be really compact and everything uses the fewest bits, it's a tough job. And I just knew that my head can't keep thinking that intently forever. The stress inside of it. Eventually you got to do something simple. Go into management. That's a joke. But you got to have some brains. I don't have the time anymore. I have a family. I actually have all the obligations that come with that. And to do the sort of engineering I did as kind of a loner, well, I could have a lab at home. I could be doing some. But the internet came, and the internet takes all your time if you let it. So I'm one of those addicts. I'm always checking all the news feeds. I got a mess of email, and I answer every fan. And I have this philosophy about not hiding out from the world. So if I ever go on to iChat, all of a sudden, instant messages all over the place, from kids I've met and stuff like that. And
well, talk about not hiding from the world.
Huh?
Talk about not hiding from the world. There's your life on the D list here with Kathy Griffin.
Total accident. Somebody sent me an email one morning and said I was dating Kathy Griffin. I said, who is she? I found out she'd said something to a reporter, and we met. We became friends. And I love comedy, so I love a humorist, and we made it out like we were dating, but we weren't. I mean, she knew I had a girlfriend, nearly married, but she didn't want Bravo to find out because then they wouldn't buy her show and give her the millions of bucks or whatever she gets for the show. And I went into the show, a whole bunch of episodes, just voluntarily as a friend to help out.
Well, you're one of the few people I know who's been on a reality show. What is it like with all these people following you around?
Well, anybody out here who's been close to a reality TV show in their life knows it's not reality. They just pre-can ideas and make a show of that they want to. I've had friends that were on reality TV shows and even wrote books about how it can destroy their lives even. You have to learn a lot about the broadcast media, and truth doesn't matter. Making something interesting and selling it matters. But so it's a mixture of real and not real.
Well, I think it is kind of funny when everything seems real and they turn around, they got a big battery pack on their back. It's like, that doesn't seem very real. Now, one of the things that I did think was really, I was a little shocked about is that Kathy had this joke where, if Oprah can go to Africa and do the Oprah Winfrey Academy, she'd do the Kathy Griffin Academy. And what she'd have is this really great computer room, and her billionaire boyfriend, Steve Wozniak, was going to come and put all these computers in there. It didn't look very computer friendly.
I spent a lot of money and bought the computers, and it was a very tiny school. And I'm the only one of my group or Kathy's group that actually spoke Spanish down there in Mexico. I was proud of that. And myself, my assistant Julie, and a guy from Apple Mexico were the three that trained the kids and the staff of the school how to use computers. They don't show that much on the reality TV show. So when the whole thing was over, the final episode, and Kathy gave a big speech, all the kids ran up to us, me, Julie, and Patricio, and they didn't know who she was.
She could be anybody.
But we'd been their friends.
But I guess I worried about. They seemed to be like it was dirt right outside the door, and I wasn't sure how good the electricity was. I mean, was the environment good enough for these computers?
Yeah, the environment there. It was kind of a nice. I would call it a little bit of an upscale suburb community of Puerto Vallarta. It was, but it was a place where they have trouble getting the kids to even come to school. So hopefully they got interested. I mean, you show them, if you have a Macintosh and you have a slideshow, you show them how to make pictures of themselves by the Eiffel Tower, and they smile, and you know what, and that brings them back. Brings them back. Eventually they use the computer for other good things too.
Other good things, exactly. Now, here's one of the questions from the web. They want to know, in your perspective, what's going on today, what are some of the game-changing computer advancements you're seeing? Like, sometimes you see something, you go, wait a minute, that's going to make a big difference.
Well, being a computer architect in the past, seeing, the improvements in, the densities of a chip, how much you get on, and then all of the parallelism and the pipelining and multi-cores and all that make our chips faster. But I learned something when I was very young. One of the first big programs I wrote was the Knight's Tour of Chess. Bounce a knight around to hit every single square exactly once. And eventually you get stuck and you say, back it up and try a different move. Back it up and try a different move. Backtracking algorithm. And nothing came out of the computer, and I did a calculation that it might come up with the first answer in 10 to the 25th years. And that told me that even though a computer can do a million things a second, the speed of the computer being very, very fast isn't enough. You need good approaches and good algorithms and good thinking by the users. So, we put out very good tools today. I think a lot of the improvement in processor speed has really shown up in the graphics world. What we can do with graphics, photography, imagery, movies, all that.
Exactly. So when we talked initially, you were spending a lot of time just trying to get the hardware of the computer together. So when was the first time you actually put a computer together?
Well, this is affordable. Thank God I discovered the microprocessor, a few years after it was out and around from Intel. And, gosh, I would have used an Intel microprocessor, but I couldn't afford it.
Well,
$400 is different than $20.
Exactly. But I mean,
but Intel was a very big part in our early Apple days because there were the RAM that was going to make a computer affordable. The 4K dynamic RAM was the first one, cheaper than magnetic core memories, and 3 companies came out with it simultaneously. And down at my club, I bought a few chips for like $12 each, bought 8 chips, and got dynamic RAMs working. I had an affordable machine in front of me, and Steve Jobs said, why don't you use Intel chips? And I said, the Intel chip's the best. It's got the fewest pins, which means less wiring complexity. It has it's the best thought out one. It's got TTL transistor levels. And I said, but the trouble is, it's Intel. It'd be too expensive. Well, Steve was not shy like me. So he went to, he just called up a rep and he got 16 chips for samples, and that put us into Intel chips. So we chose the right RAM.
Well, this actually goes to another.
Doesn't the little I, and I kept saying, doesn't the little I that we have on our products today mean Intel? Or for the old timers, was that Intersil?
Well, this actually leads me to another question, because a lot of times you'll be an engineer, you'll be down there in the trenches, you're really going to make this thing work. There are any number of great inventions that never got anywhere because it was just an engineer. You need to have some complement of people around you. So, enter Steve Jobs. To you, who was Steve to who was you that made this go? Because there are many other people at Apple that were the key partners. Why did that work together?
Well, a lot of times you become what you want to be in life, and I wanted to be an engineer. Did not want to ever run a company, didn't want to ever have money, didn't want to move up in a management chain, wanted to be an engineer for life at a big engineering company. Hewlett-Packard. It's Agilent now. But Steve had these dreams of being one of the great people that has companies and makes products that change the world, and one of the few people, that the Shakespeares and the Einsteins, that get well known, and that sort of. He wanted to be in that group, the way he talked. So every time I designed something great, from when we were very young, he would say, let's sell it. It was always his idea to sell it. And the Apple computer was actually the fourth one. The Apple II was the fourth time he did that, where we actually took one of my designs and sold it and made a little money.
It's interesting because you were saying that the Apple II didn't really take off until VisiCalc. You needed an application.
Yeah, the real home computer revolution, started. It had those creeping starts where things are, but all of a sudden we had a floppy disk for speed and VisiCalc the program. That program was the first time that a small computer did more than a big computer. It did something so useful for a small businessman, could type in month by month by month by month the income and outgoing expenses of his company and make projections, change a little bit of when I'm going to buy erasers and when I'm going to restock this, and wow, and in half a day of playing around with a spreadsheet, these small businessmen could have spent 10 years with pencil and paper doing the same work. They'd buy that instantly. It was a must-have application. So that was the first killer app, and that really defined personal computers. Just shot up as so valuable. Now, other computers besides Apple, we sort of went towards the business side after that, but other computers like the Commodore 64 came in, filled in the gap in games that we had started.
It has to be useful, and until it's useful, it can't really take off.
Yeah, and at first we were still successful even without VisiCalc, just with games. We were successful as anyone would judge themselves in life. Remember, Steve and I were in our young 20s when we started it. We had no money, no savings account, no cars we could sell, nothing. We had no business classes, no business experience, just sort of trying to make common sense decisions. And what can you do with the little bit you have? What can you do one step at a time? We formed the company to build PC boards for $20, sell them for $40. Right away, got an order for 100 pre-built computers with all the chips in them. We couldn't afford the chips, but the buyer, the store in Mountain View or wherever, said he would pay cash. So we got 30 days credit on the chips and built the machines up in 10 days, and we got paid cash.
And
after half a year, we built up about a $10,000 bank account, which was pretty
seemed
nice.
like a lot of money.
Yeah, my salary at those times was $24,000, so it was enough money. Even though we didn't pay ourselves salaries, we didn't run it as a business, it couldn't have added up to a realistic business person. It was a start that got us to the next step, which was the Apple II, and to the next step.
It's interesting because when you started Apple, you and Steve both took 45% of the business, and I can't remember who took the 10%.
Yes. When he said, well, first of all, I had already given that computer away, the Apple one. I'd given away the schematics, the listings, no copyright notices. I helped other people build their own. Steve said, let's build the PC board, then let's sell some built computers. And we formed this little partnership called Apple, but first I had the strong ethics. I would not sell something for money without my employer getting the first cut at it. And I tried to pitch it to HP, and I was turned down for the first of 5 times. And then I got really scared when we got a $50,000 order, and I went back to HP's legal department, had them circulate my description to every division, because I was never going to leave Hewlett-Packard for life. We built the tools that engineers used, and engineers were respected in the company, and that's where I wanted to be forever. So I forget what the question was, but
rejection,
I'm off track. But what?
Silicon Valley, we eat rejection for breakfast, So. but you turned around. That is interesting. Yeah, I can't remember what the question is either. Anybody can volunteer.
It was the Apple. Yeah. No,
I know.
That was the Apple one.
We started out when you started Apple, it was.
All right. Steve had 45%, and I had 45%. And he introduced me to a friend of his, Ron Wayne, who spoke in very absolute answers to everything business terms. Like we were young kids, and he was like the adult who'd been through it a whole bunch of times. He was also a very conservative type guy, right-winger. He'd read all these books, None Dare Call It Treason, and he carried his money in gold nuggets.
Where's he today?
and actually what happened was we got to this point where Steve and I were getting credit and being paid cash, but what if we didn't get paid? Steve had no money. I had no money. They'd come and take Ron's gold nuggets from his mattresses, so he sold out for a few $100.
He sold 10% of Apple.
Instead of taking the risk, and it might have been a reasonable decision under when you can't see the future. If you say, "Oh, I'm taking all the risk and I only have 10% of the company."
Now you're still affiliated with Apple.
A little bit, yeah.
Just a little bit. But over the years, we've watched a lot of things. We've watched Steve Jobs go. We've watched Steve Jobs come back. How do you view this? You have to feel really great about Apple, and it's been through some tough times and some great times.
Well, I always felt very positive on Apple, and I felt that Steve's leaving was a little bit of disloyalty. And when he came back, I wasn't totally satisfied. But after this amount of time, I'm very, very glad that he's in there, because he got a lot of our original values of we want to build good products and not just schlocky anything in the world. We don't want to be a sales outfit. We want to really change the world by making things so special. You've got to have it. And I've seen that happen over and over and over. When he first came in, it was the iMac got introduced. Well, that was already in the works at Apple. We had already hired the designer, Jonathan Ives. But, over time, products like, well, the iPod and the iPhone, you just can't say more than that. So I'm very, very glad and impressed and happy, and I think Steve's got that one mind that basically controls the products to keep them that good. It's real easy in a large company to have all sorts of junky things slip in that shouldn't, especially in computers.
What was your reaction when you realized that Intel chips were going to go into Apple?
My reaction was good, because I believed what I heard on stage with Steve Jobs announcing that the low power roadmap of Intel really fit our needs for chips in the laptops. And any computer architect knows that power is really the limiting factor. You've got to design things for low power to get more performance, more speed, and we love our laptops these days. So that was the right decision. And there were a lot of people that were upset because IBM had groups that were really out there doing some incredible research and developing great products, and wanted to be the Macintosh against Intel. But they got swayed by the Sony game machine. And that was their big buyer now. And Apple, they weren't going to do what we wanted as much, and Intel worked with us better. So, I'm very happy. And we were to the point that the chip didn't matter. I mean, the original NEC software and became the Apple software really was developed on Intel platforms anyway. And we just, we could develop, the code was often developed on Intel platform, but we ran it on the IBM PowerPC.
You say you got to believe in yourself, never waver. Why is that so important?
Well, you know what? You should feel, if you have technical ideas, well, maybe you feel, I really don't know what I'm doing. But if you know, I solidly in a certain area in life, it might be technical, it might be sociological, it might be a counselor, but you know what you're good at, and you know your reasons for doing it your way are right, even though other people go with a different way. Yeah, you have to shut them out and say, I don't care. I know that what I'm doing is right. And it makes you feel good about yourself. It could even boil down to values in life. My values, I don't have to convince everybody in the world to be like me. They can believe what they believe, and I can believe what I believe, and I'm just happy in my own beliefs. I'm happy with who I am, and I don't have to be unhappy because I can't convince the world, to be for or against, some candidate or something political, something like that. So it's a light way of going through life very happy.
You always wanted to be an engineer. You got to be an engineer at Hewlett-Packard. That's all you wanted to do.
No.
And then
not all I wanted to do.
Oh, okay.
I had two goals. I told my dad when I was in 6th grade, I said, I want to be an engineer like you. And second, I want to be a 5th grade teacher. And eventually I went back and I taught 5th graders and then older students and teachers for, I got to where I was teaching 7 days a week did it for 8 years. No press. I didn't want, I'm sorry, awful press monsters who can lie a bit. I didn't want them around children.
Well, when you're an engineer and you're in the media, you get a little conflicted. I don't know what to say. Well, I guess my question was, though, at the time, you really loved being that engineer. And here you are starting Apple, and it's like, at some point you had to make the decision to leave Hewlett-Packard. That must have been hard.
It was extremely difficult. I had the Apple II design. We knew that it was going to sell real huge, but we needed a lot of money. And after going through a lot of avenues, we found an angel that was going to put in the money. And he said I had to leave Hewlett-Packard. I said, wait a minute. In 1 year, just moonlighting, I've developed 2 computers. I've written a basic language. I've done all the software needs, the technical. I put in stuff nobody ever imagined in low-cost computers, color and graphics and pixels. And he said, nope, you got to leave Hewlett-Packard. And he said, well, decide by Tuesday. And on Tuesday, I went to his cabana with Steve Jobs, and I said that I thought it over, and I was going to be myself. I wanted to be a Hewlett-Packard engineer forever and design computers for fun, and I can always design computers at home for fun. So I don't need a company, Apple. And I said, no, I'm not going to start Apple. And Steve Jobs got all my friends and relatives to start calling me, take the money, do this, start this company. And one friend convinced me, you can take the money and be an engineer, and you don't have to run the company. You can be an engineer for life and just use the company to make money off of it and get rich. And I just was afraid to run a company. I'd be thrown out. I couldn't be political and step on people's toes. I just am objective, and I like to make the right decisions for the right reasons and do my calculations. So that day, I left Hewlett-Packard that day. Once I realized I had one other person saying it was okay to start a company and you have to be more than an engineer. So I'm proud. I've been at the bottom of the org chart of Apple since it started.
Were you employee number 1, 2, 3?
1.
You employee number 1?
We had a president who we hired from a national semiconductor division, and young Mike Scott, and he ran Apple until we went public with a very huge, glorious, one of the greatest, startups going public of all time. And he was great. But I think he realized that the computer had started with the engineering. See, I had the computer before we had the company, before we got any money. The computer was all done, being shown off. As a matter of fact, Mike Markkula brought me into an Intel staff meeting, the highest level staff meeting, to just show this little board with a bunch of wires, snaked a wire over to my TV set, went inside of it and typed on a keyboard a bunch of hexadecimal data and made colors appear on a TV screen. And right in an Intel staff meeting, I didn't realize how rare and impressive that was. They respected Mike, who was our funder. They respected him a lot. So I don't know. It was so we had at least a product to start with. So I got number 1 for employee number.
Well, that is great. So
I didn't ask for it. I don't care.
It's pretty good employee number 1. You still have your ID card?
But sometimes I go into an Apple store and I say, yeah, I'm an employee. I get a discount. What's your number? I say 1. Huh?
I love it. So you take the discount, huh?
Yeah.
And when
I never use my higher discounts. If I go to a certain store, I'll get 15% instead of 10, and I get 25% once a year. I never bother with the time to do it on the inside computer systems. And I don't ever ask for products for free. I just don't believe in that. I don't want to do that.
In fact, when the iPhone came out, you stood in line with everybody else.
Yes, that's right. And the second time I did as well. And I did not cut in line, despite publicity that said I did. It's really interesting. I wanted to say these press guys that wrote stories like that, they get seated first at Macworld shows, our Apple Mac World shows. They get seated first in the prime seats. They aren't cutting in line. I'm sorry. It's there. You're in first. You're the first group.
Well, let's give you a chance to clear the record, because you've had a number of things reported about you and about Steve Jobs that really weren't true. And so why don't you just clear the record, for all the media? See, because the truth is you're right. If you're an engineer and you make a mistake, it doesn't work. So everybody, it's like there's no denying it. But if you're in the media and you make a mistake, it gets replicated everywhere with the internet. So.
Well, blogs. Now we're in the days of blogs, so everybody has an opinion. Opinions get replicated. You don't have to have, facts don't even come into play very much. It's hard to tell, what you're reading, what's true and what's not. So, and I don't like any of the articles that put people down, like Steve Jobs. They love to jump on the famous people because it sells things. It's popular. Everybody wants to see heroes beat up.
Well, it's interesting about heroes. It's like I think we all have them, and everybody is. If you're human, you've got some feet of clay in here someplace. But that doesn't mean you're not a hero. Who were your innovation heroes growing up?
It's so hard to go back and say. I read computer manuals, and I would look at somebody's code and see a name on it. Ed McCracken, I can't remember all the names.
Yeah.
I would see the names. Wow, these were my heroes because I was learning from their code, from their circuits. And so when we came out with the Apple, that was the reason I made sure all the schematics got published. And basically, I wanted it to be a training manual to other people. How computers work in hardware, how they work in software, how to use it and get something done. I really wanted to give back the way I had learned to so many of the young people that would discover, hey, this computer stuff doesn't need higher level math like calculus. This computer stuff, you can write programs and know more knowledge than you have in 5th grade.
Well, it's really very interesting because I always knew you were, into everything we've been talking about, but I had not realized how wide your interest had become. When I wrote this book about the biotech nation portion of Tech Nation, I actually got into biotech after all these years of doing everything else. You show up at Kepler's, and then they were very excited. All these people are showing, it's jammed. We're so excited. And then Steve walks down the middle of the aisle, and then they do triple somersaults. Oh my goodness! And they're like, why would he be interested in biotech? And then you said, hey, you got to talk to me. I got a friend you got to talk to about the Genome X Prize. Remember this, Mark?
That's
Hodash?
right. Yeah, Mark Hodash. Yeah.
Hodash, exactly. And it's like, why would a Steve Wozniak be interested in the Genome X Prize?
Well, I don't know. I had a friend that was doing it, and my co-writer here had written, Gina Smith, on my book, had written a book on genomics.
The Genomics Age.
I mean, we know how important it is, yeah. But I just, anything's interesting. If I see, here's a speech tonight, or here's a concert. Yeah, I go to them all the time because I always want to have a middle life that I can just go out and kind of live a life like other people do, entertainment included. So going to your book signing, that was kind of like entertainment. I get to hear from interesting people what's going on, you know, and
of course, there's a lot of computers in there anyway.
Fortunately, there's laws of physics. There's only 24 hours in a day. And you want to go to 100 things every day.
But I think that's just it. All this interest you have in so many things, and one thing leads to another. I remember you saying about the Genome X Prize actually offers $1 million, $1 billion, I don't know how much, to do like 100 human genome decodings in 10 days. It's trying to push that technology. And you were talking about trying to motivate people and groups and things to focus on how do we push that innovation forward.
Yeah, a lot of these, you know, big contests with a lot of money. I mean, I'm not sure the X Prize for the space launch and all that really necessarily leads to something, but it might. You have to keep trying. Look at the people who, you know, first tried to cross the Atlantic without any power, and the first people that flew planes across the Atlantic, and how, you know, it really spurred us. Look at the space race and how it got us chips.
Well, look at the space race. Everybody remembers John F. Kennedy saying we're going to go to the moon, but he also said, like, 4 seconds later, and we're going to put all these communication satellites up, and hence we got all the cell phones and all that. If we didn't have the communication satellites, we wouldn't be here. That was the 60s. Now it's 40 years later. Well,
it's a great change in our lives. But we always wonder, technology is always supposed to improve our lives, right? So, wow, it's going to make us happier because we don't have to spend as much time. Life is easier. We have more leisure time. And I don't know, are we happier than they were 100 years ago? Are we happier than they were 1,000 years ago? Or did they smile as much per day? Probably, I don't know. It's hard to say.
They can't do any more than 24 hours because that's the time you have.
But we've got to believe that our technology is getting us to heaven.
At some point. Well, speaking of time, you always have a great watch. What do you got on there?
It's a watch made out of old Nixie tubes, 140 volts. And it's waterproof, but I'm not going to test the 140 volts in the bathtub. And when I turn my wrist, it shows hours and minutes on Nixie tubes. And I love the time coming at the rate I would speak it. 8:54. It's just, it actually gets to my head quicker than looking at a watch and figuring out where's the time and what it is and what's before the call and what does that mean in the day. This is the best way for me to get time. So that's why I wear it, not because it's weird.
Well, what do you wear because it's weird? Oh, no.
Yes. I'm a gadget person, so I buy lots of interesting gadgets that do weird little things. You know, I was into early flashing lights and lasers before they became known. And I buy all sorts of weird little gadgets, strange watches, show them off for a few days to my friends, my gadget friends. And then I go back to my normal, like an analog, beautiful watch. This is one of the few gadgets that I stuck with forever because I just like what it does.
Now
Segway, that's another one.
Oh, Segway, yeah, exactly. How many Segways do you own, Steve? Share that with us.
I own a lot of Segways. I use them in every part of my life, and that means I go from my home, instead of a bicycle, I just take a Segway down the hill, into town, park it in the movie theater, watch a movie, ride it back, and I get to skip that whole big car.
You took a Segway over here.
So many things in our life are just so much bigger than we need on occasion. Segway gets me around. Yeah, and I carry it in my car, so when I come to San Francisco, I have a Segway. Gets me up and down the streets and around to different places so well in all the cities I go to, and I'll rent them even in foreign cities, and I play Segway Polo.
And you're about to go to Germany.
My team won the World Cup of Segway Polo 2 years in a row, but we just lost it last week in Indianapolis. We came in second, but I get to play in the Euro Cup. I'm going to play for Germany against Switzerland on September 14. So I'm the first transcontinental Segway Polo player.
But I think the thing that's fun is that you have Segways all over the world. In fact, you have two, so you always have a buddy, right?
Well, I have lots of more than two Segways, but I have two in the car this trip, and I have very often I'll take a trip to L.A. or Las Vegas, take friends and 3 Segways and 3 people. All fits in my Prius. You know, I'll tell you, a hatchback is a really efficient car. I always think in terms of efficiency. You want things smaller, but you still want them to do a lot.
Now, you knew what you wanted to do when you were going into college, if you will. You knew you already had your dream about building computers. You loved electronics. You loved physics. You loved math, a lot of math and all that. If you were going into college today, given the young man that you were, would you be studying, you think, the same things? Because they just intrigued you?
Oh, yeah, absolutely. I'm sure I'd be into whatever kind of engineering or computer science there is today. When I entered college, there were virtually no colleges in the country that had computer science as an undergraduate curriculum. As a matter of fact, the college I went to, I was a freshman, but because I was enrolled in engineering, I was allowed to take Introduction to Computers, which was a graduate level course. And I got an A+ in it, but I wrote so many programs, I ran the class over budget. I didn't think they had money. I didn't think they had budgets. I ran them over budget, and they made it sound scary, like it'd be hard for me to go back to that school.
There are all these people in the class, but you use the entire class's budget.
But yeah, and I'd be doing the same thing. But see, I never had to worry about what am I going to do with college because I was so smart in electronics that I'd always have a job that I would like my whole life. I never had to think, what am I going to do when I get out of college? I knew from very early on.
Now, we have such things as like...
By the way, I did go back to college and got my degree at Berkeley.
Yes.
Went under a fake name, Rocky Raccoon Clark. And the teachers all called me Rocky, and the diploma says Rocky Raccoon Clark.
And that's you, right?
Because, you don't get two chances to do something like that in life. But I wanted my kids to see they had a dad who had a college degree because it'd be an incentive for them.
And what did you get your degree in?
Electrical engineering and computer science.
There you go.
Double degree.
There you go. It was appropriate. And actually, if you went back, did you get to use your old transcripts?
I don't know. Oh, when I went back? Yes, I went back 10 years after I'd finished my third year at Berkeley. So when I went back, I was just in the squeaky period where you didn't, where it could still apply.
It could still apply, and you could
yes, thank heavens. Well, no, I'm glad to have done that. I had a plane crash, and right when I came out of amnesia, I called up Steve Jobs and said, I'm going to go back to school and get my degree. It's the most important thing that was easy to do. 1 year of college. Why would you put it off forever and never get it?
And finish it off. So I guess you didn't really learn anything groundbreaking, but you did complete it. And that's
I actually learned some things in that course. No, you're right. That year. No, I took mostly psychology courses to study what happened to my head after my plane crash. But I didn't. Yeah, but I had actually learned some things at Berkeley in my third year of college that I applied that learning to some Apple projects. Very often your real learning, that the work that you do in business, you've learned it on the job from other people. You've seen how it's done, or you talk to people in restaurants and share stories, and you look in manuals, and you don't necessarily learn the exact stuff you learn in school. This is exactly what I'm going to apply when I work. Not necessarily.
There's a lot of people would think, okay, part of the time you were this, engineer, really out there being an engineer. Oh, and then you went and were a fifth grade teacher. You were taught all kinds of things. That has to be a completely different person. There's got to be some overlap there.
No. Like I said, I had both those goals in my head forever. When I went through college, I always paid attention to anything that touched on child psychology, child development. And actually, when I was in my third year of college at Berkeley, I discovered that, boy, this psychology, it's like a child growing up, a young baby growing up, is like a development of a computer. And it was just intrigued me actually from that viewpoint, and I hoped that someday I could actually teach. So it wasn't like just a flighty fancy. It was something I'd intended.
But there had to be some overlap between your experience of being an engineer and your experience of teaching.
No. When I taught, I decided I taught computers voluntarily, and as a volunteer teacher, I had a lot of freedoms normal teachers don't have. If I teach poorly, I'm unhappy. And then I could go back the next day and reteach the same thing. A normal teacher has to go to the next pages in the book. So I was sort of outside the system and couldn't fail. And it was a lot of fun. I could teach the kids how to be computer scientists, but then that would hit a few of them would be special and stand out. I decided instead, take all the normal fifth grade classes, everything they're doing in school, and teach them how to make their homework look good to the teacher. How to make it more presentable, how to mix graphics, text, what fonts to use, how to space things, as well as how to use networks, as well as the things we do in normal life. But if they had an assignment in school, I would think of, here's a way we can do a spreadsheet to count how many A's, how many B's, how many C's there are in a certain sentence. And then I would take it to show, here's how you use the computer as a tool to help you with other things you have to do.
Like compress your teachers.
And that way I was able to reach every single kid it applied to, yeah.
Because everyone's important.
They did beautiful work, but I found out that after they got past me into other schools, I'd go to the parent nights and look on the walls, and they went back to some simple, fancy, kiddish tricks. The teacher level, if the teacher level's low, the kids won't go high. You want the instructor level high that knows what to expect from the kids to get them to perform at that level.
It reminds me of your father working with you when you were young.
My dad, I was really lucky to have him because he didn't force any values or ways or you should be doing this particular thing. But when I had questions, how does a transistor work? It might be something that simple. He would go on a blackboard and explain it to me and make it very understandable and very clear. And he also knew to start with the basics, atoms and elements and how they're constructed, and then how electrons flow through wires and eventually transistors and then gates. So he went in a step-by-step level, which is the way we best learn. You try to teach somebody something way over their level, and maybe they can seem to do it. maybe a kid in 5th grade can seem to do a spreadsheet, but they don't really understand it. And so he didn't skip those steps, so I had a very good learning with him as a dad. And he also impressed a lot of really good values on that. It's what I am today, so I'm so proud of it.
Now, after this, Justin's actually going to talk, and then you can just go right outside, and I think it's downstairs. Steve is going to be there signing his books. I'm going to be there signing my fewer books, obviously. But actually, we should probably sign our books for each other right now. This would be really good to show you how you do it. And I just wanted to actually mention to you that, last year, Gordon Moore was the person that I interviewed for Intel Developer Forum. And I actually ran into him a couple of months ago. And I said, hey, who's gonna follow you? And I said, Steve Wozniak. And he goes, oh, I have a story about him I don't think he knows. He goes, his father was a Lockheed engineer, which is true. And he goes, he called me up one day. DRAMs had just come out. And he said, my son is really interested in DRAMs. So he says, I sent him some. He goes, I don't think he knows that. I said, oh, that's really interesting. And he says, I always wanted to learn how to ride a Segway. So I thought maybe, if you're over in the Big Island of Hawaii, you could bring one of your Segways.
I am a teacher by heart. And on the Segway, I am a good teacher. I make sure the first steps are the most important ones, that it's successful and happy.
And so then we can bring the video maybe here to IDF and
yes.
show everybody Gordon and Segways.
Yes. And I have other former CEOs that have been trained by me on a Segway and have bought them from me.
A dealer.
Yeah.
Yeah. Thank you very much, everybody. Steve Wozniak.